Welcome to Lesson 46, Part 2. This is the last and final lesson in Unit 7 Solutions, meaning your unit test is coming up. In this lesson, we are going to look further into solution concentration by learning how to calculate parts per million and percent composition to express the concentration of a solution. Parts per million is a way of expressing solution concentration where it's 1 out of a million. We use parts per million when a small amount of solute could have a large impact on the quality of the solution. One example of this is when we measure the amount of lead found in either human blood or drinking water. We use parts per million, as a very small amount of lead dissolved can have a very large impact on human health, particularly on developing brains. We also use parts per million to measure the concentration of other metals in water that might cause something called hard water. When water has metals such as calcium dissolved in them, they can go and clog pipes and cause other plumbing problems. They also can alter the taste of water. Luckily, New York City drinking water does not have many dissolved metals in it and is quite delicious. So the formula for calculating parts per million is found on reference table T. Here we know that parts per million is equal to the grams of solute divided by the grams of solution. A solution contains both solute and solvent, and we'll multiply this times a million. 10 to the 6th is another way to write the number 1 million. Let's do some practice parts per million questions together. In this question, we were asked to calculate the concentration in parts per million of 0.015 grams of lead in 10 grams of solution. So here we're going to take the grams of the solute and divide by the grams of solution and multiply this times 1 million. Using my calculator, what I'll find is that this is 1,500 parts per million. This next parts per million problem, we are given a mass of 0.0035 grams of hydrogen sulfide, and we see that it is dissolved in 10 grams of water. So what you can do is divide the grams of solute by the grams of solution. Technically, we would need to add the grams of solution here, but because the grams of solute is so much smaller compared to the grams of water, that won't be necessary. Our mathematical answer will come out the same, so you can do either way. I'm just going to make this a little easier. And now when we substitute, we'll get that this is 350 parts per million. Let's try this question together. If 0.025 grams of lead nitrate is dissolved in 100 grams of water, what is the concentration of the resulting solution in parts per million? So we can see that the grams of solute is 0.025 and the grams of solution is 0.025 plus 100. We'll multiply our fraction by 1 million for parts per million. So putting this in your calculator, you'll get 250 parts per million. Now let's try this one. What is the total mass of solute in 1,000 grams of solution having the concentration of 5 parts per million? So all we're going to do is substitute. So we're looking for the grams of solute in 1,000 grams of solution multiplied by 1,000,000. That all should equal 5 parts per million. So we can easily solve this using simple algebra to isolate x. So in order to get x by itself, the first thing you should do is divide both sides by 1,000,000. Then you will multiply both sides by 1,000 so that you can isolate x. So once you place this in your calculator, you should get 0.05 grams of solute. Notice that the grams of solute are very small in parts per million. Now occasionally, the concentration of a solution can be represented in either percent by mass or percent by volume. For both of these, we're going to use the percent composition formula where we're going to take the part divided by the whole times 100. So the difference between parts per million and percent is parts per million are out of 1,000,000 and percents are out of 100. So here you can see we're asked to calculate the percent when in 100 grams of solution there are 2 grams of salt. So we're going to take the part divided by the whole times 100. And our answer will come out to be 2%. In our final example here, we are given that the percent composition is 31%. And we are looking for the amount of sodium hydroxide. And we see that we have 240 grams of the solution. So the solution is the whole thing. And we're looking for the part that is the solute, and we'll multiply this by 100. Putting this in my calculator, I'll get that 74.4 grams of sodium hydroxide must be dissolved in this 31% solution. This concludes lesson 46, part B. Make sure you bring any questions to class. This is the final lesson in Unit 7, so expect a unit test soon. See you in class.